All right. Speaking of hygiene, next we have Hygienic Macros via Staged Environment Machines by Yuito Murase.
Hi, I'm very happy to be here and have opportunity to talk about our ongoing project so it's about the relationship between hygienic macros and staged computation. So basically, it is known fact that hygienic procedure macros and staged computation are somewhat similar. So it's about generating code fragments at compile time stage that will run at runtime stages. So hygienic procedure macros are more about language design or implementation things. And it has less known theory in the context of lambda calculus. On the other hand, multi-stage computation arises from lambda calculus context. So it's natural idea to apply multi-stage computation to hygienic macros to establish hygienic macros with solid theoretical background. So there are some proposals, and they are successful to some extent, but so there are still some gap between these two. And in this talk, I want to highlight the difference or similarity between alpha renaming in multi-stage computation and explicit renaming. So this is a hygienic facility in hygienic macros. So let me quickly introduce this explicit renaming thing and alpha renaming. So, macro is about extending syntax of the host language by macro expansion. So if we want to have or macro that takes first argument, if it's true, it just returns that result. Otherwise, it evaluates and returns the second argument. Then we can define this or macro by providing this expand result. So it evaluates the first argument, binds it to temp. Then we just use the if statement. So it just works. But so here we see that it introduced new binding with named temp, which introduce sometimes the issue. So let's say this example. So here we use or macro with the variable temp. So this seems working, but it doesn't because or macro inserts new binding with the same name, which blocks the binding of outside. Then as a result, this temp refers to this one, which is not expected. So that's how name conflicts makes macros unexpectedly. So basically, that's the problem what hygienic macros tries to resolve. And so idea is very basic. So for each binding, we introduce new names, unique names for these bindings. So now we can see that these temp1 and temp2, so they are originally the same name temp, but they are renamed to unique names. Then in this way, we can ensure that bindings inserted by macros will not block other bindings. So although this idea is very simple, so there are many ways to implement or achieve hygienic macros. So there are many mechanisms or algorithms to achieve hygienic macros. And here, in this talk, I want to highlight explicit renaming macros. So because it is one of the most primitive and concise interface for hygienic macros. So in explicit renaming macros, or macro is written in this big thing. So it's a bit bothersome, but because it's a very primitive interface. So basically, it's procedure macro. It means that or macro is defined as a function in the host language that takes source expression and it returns an expanded expression. So you can see this quotes generates expanded expression. And you can also see that this lambda takes two more arguments. So that plays an essential role to achieve hygiene. And let's focus on this renaming function. So this is a function that takes raw symbols and it resolves its name to unique name corresponding to its syntactic environment. So for example, if we call renaming function with let, the symbol let, then, so in this context, let means that in standard library, then renaming function returns a unique name that always looks at let in the standard library. And if we give temp. So in this case, temp is not defined in this context. Then renaming function just returns unique name so that it will not conflict with other bindings occurring from temp. So that's pretty much. So explicit renaming is basically procedural macros, and it uses renaming function that resolves names to unique names. And programmers have responsibility to perform appropriate renaming. So yeah, that's the basic idea of explicit renaming. Okay, then let's look at alpha renaming in multi-stage computation. So multi-stage computation, so here I mean query quotation-based language like MetaML or MetaOCaml. So this is MetaOCaml program that does very similar operation as OR macro. And so you can see it has query quotation syntax. So it's MetaOCaml way to represent query quotation. And it generates a program that behaves as OR. But here you can see this temp has binding relation. And so alpha renaming basically says that we can just rename these names with binding relation at any time. So we can rename this to ABC or PPP. And so all these programs are just same under alpha equivalence. Okay, then let's consider evaluating this program. So here we can see two different binding relations there with the same name. So if we don't rename them, then it will conflict. So we just perform renaming on one of the binding. Then that's perfect. So it doesn't break binding relation. And yeah, so alpha renaming is just says that you can rename bindings to avoid conflict. And so both alpha renaming and explicit renaming make sense, but they appear very different because explicit renaming is very explicit procedure where a programmer can manually perform renaming. Meanwhile, alpha renaming is very implicit one, so it is separated from operational semantics, and so it can be performed non-deterministically. So I think many people think explicit renaming and alpha renaming are just different things. But so in this talk, what I propose is adding intermediate step to compare them. So here, the intermediate step I add is, so it's also multi-stage computation, but in more elaborate operational semantics. So here, I call it environment mapping semantics. So in this staged variant of environment mapping semantics, then alpha renaming is elaborated to more elaborated steps for renaming, and it is now explicit and deterministic, so it is much easier to compare these two. Okay, so let me quickly introduce how environment mapping semantics works in staged computation. So it is actually the intermediate state of evaluating staged program, unlike MetaOCaml programs. And this consists of 5 elements. So this yellow part is expression under evaluation. And we have level of that expression. So 0 is for runtime stage, and 1 for level inside code generation. And we have a deeper level for deeper nesting structure of code fragments. Okay, and we have evaluation context or continuation. And we have 2 environments. So this value environment is the standard one that maps variables and its corresponding value. And in addition, we have extra environment, which I call renaming environment. So that maps raw names to its corresponding unique name. So basically, this plays important role to achieve hygiene. And let me quickly explain how this works. Okay. So when evaluating this program, then we first evaluate this one. So get the content of A, then embed it here. Then we get this as a generated code. Then after that, we look into let binding inside code. And at this point, so machine will generate new name. So temp1, and then it has new, so that mapping into renaming environment here. Then, so according to renaming environment, we perform renaming. So this temp is renamed to temp1, and this also renamed to temp1. Okay, then finally we get this code fragment, and so we can see that renaming is performed appropriately, and binding structure is kept. So yeah, that's pretty much the basic idea of environment massing with stage computation. Then the step from this massing to explicit renaming is somewhat straightforward. So in environment massing, variable name is automatically renamed to temp1 using renaming environment. But what if we introduce explicit reflective interface for renaming environment? So we have a rename function, and it takes a row symbol, then it returns a corresponding name according to renaming environment. Then it just returns to temp1, and so that's pretty much it. So the message in this talk is explicit renaming is. So it can be considered as a reflective interface to renaming environment. So going back to high-level description. So yeah, I just say that renaming function can be explained as reflective interface to explicit renaming. And also, the step from this one to this one, so elaborating semantics, is kind of standard technique in Lambda calculus. So there are many work on this topic. But so especially talking about stage computation, there's work by Gay and Garcia that elaborates semantics of multi-stage computation. So they make environment massing semantics somewhat similar to our environment massing. Okay, and so that's pretty much about my talk. So you can check out my paper for more discussion about it. So I provide full semantics for staged environment massing. And so I made a draft design for abstract machine semantics for explicit renaming macros, but I'd say it is very incomplete because there are still many gaps between multi-stage computation and hygienic macros, so you can check out paper for discussion. Okay, and key takeaway. So basically, so explicit renaming might appear just an implementation detail, but I think it has a theoretical background, so that can be explained by alpha renaming. And the second message is, so here I quickly introduce staged environment massings, and I think it's very interesting subject object to dig in, but there's still little work on about that. So I think that's something that interesting to work on. And yeah, that's pretty much that I want to talk in this talk. So thank you for listening.
Any questions? We got plenty of time for them. In the back here?
At this rate, I should just sit in the front row. I like that you're exploring this work, and I want to talk to you more later about this. But what do you see in terms of where this work could go in terms of new features or functionalities that might be accessible with this sort of model of macros and hygiene?
Sorry, I didn't catch where.
Okay. What features do you think? What future results do you think that this model of hygiene could allow us to access?
What feature? Let me see. Not sure if I understand correctly, but so in future, I think coming up with full model for programming. I want to come up with operational semantics for programming language with procedure macros. So basically, explicit renaming is hygienic macro, but so it is procedure macro. So it should include operational semantics of the host language. And so there are many formal models considered for hygienic macro expansion, but they usually don't include operational semantics of the host language. Then so it lacks the interaction between host language and hygienic macro expansion. So I want to make something that covers this area. So does that under your question?
Yes, thank you.
Any other questions? Okay, I'll ask one then. We have lots of experts in this room, and you said there's still some things missing. Do you want to speak a little bit about that, and maybe someone will try and find you in the break and
so you
exchange
asked
ideas.
for what is still missing?
Yes. Yeah,
okay.
yeah.
So I said that explicit renaming can be explained in perspective of staged environment mass things. But so the remaining gap between these two is, so basically hygienic macro is about expanding from S expression to expression. But in multi-stage computation, so they represent code in more opaque data. So that is generative code fragment. So these two are basically just different things. So the biggest difference is that Kyoto in multi-stage programming is structured data like AST, so where binding relation is very clear. Meanwhile, S expression is just binary tree where it can have symbols or maybe natural numbers or those atoms on leaf. And so we cannot find binding relation at the first sight. So the programmer can find binding relation. And so at present, I don't fully formalize this difference, and that's something I need to work on. Do I explain?
Yeah, that's great. So if anybody knows about binding, come find Yuito. Any other questions maybe that came up from that discussion?
Jason Heeman, Seton Hall. We know the stories and discussions about explicit renaming versus implicit renaming in different hygienic macro systems. Now that we've got a way to relate certain kinds of multi-stage computation to procedural macros, and we know the pros and cons of various kinds of macro systems, is there an analogy between different kinds of multi-stage computations, and what can you say about that?
Sorry, I'm not quite sure what the point you want to ask. So could you rephrase?
We've got an analogy going this way.
Yeah.
And we've got we've got relationships going this way. So complete the diagram for me.
I see. So So what you mean is, there are different kinds of hygienic macro facilities. And you are interested in maybe what ideas in multi-stage computation corresponds to other macro facilities? Exactly. Okay. So basically, my idea is a bit different. So I think every macro facility can be derived from alpha renaming, hopefully. So I don't say it's possible, but that's my conjecture. Then there may be derivation path might be a bit different, but I believe every hygiene thing can be derived from alpha renaming.
Okay, thanks.
All right, let's thank Yuito again.